Get moving in about 2 minutes or so, 3 minutes. So there's only a couple people in, but assume there'll be a flood momentarily. If not, that's fine too. Okay, got a few more people coming in. Wait just a minute, and then I'll get us kind of started. And then most of today, I'll really just sort of be, I'll show the basics, the very like where to start opening and creating one of these files, how to kind of get yourself started. Maybe some don't mess with these things, do mess with these things sort of warnings, but then they'll mostly be sort of soliciting questions, being like, how do I do this thing? And then I'll try and give you a hand. We're at 9, it seems fine to me. Okay, so like I was just saying, this is kind of a free work and you don't really have many tools to work with at this point, right? I've basically shown you how to open a document and write some stuff in it, giving you a couple pieces of basic code in the lecture and told you to mess around with some data set, right? Okay, so why don't we just start here from scratch and just so you can kind of walk along with me in your R Studio and make sure you kind of got the steps necessary to build out one of these basic documents. So what I'm going to do here is I'm going to go ahead, go up to File up here. Sorry if the text on my menus is small. My monitor is enormous, and that's the only part of the interface that doesn't blow up when you increase the percentage size of the text. So you got the tiny little text. I assure you I have pressed the File button in the top left and gone to New File. In New File, I can go all the way down to R Markdown, period, which will bring us up a dialog box like this, where we can select what type of document we want to produce. Generally in this class, we're just going to produce sort of what the default is here. We're going to produce a HTML document and knit into which is essentially a little self web page. There's a lot of other stuff you theoretically do here. There's different presentations, there's interactive shiny dashboards, and there's also templates. And if you're like me and you've customized your R a bit, there's a lot of different templates for interest, like specialty presentations, certain types of like letters, CVs, and stuff like that. Sometimes even journals. But we're just going to stick to document up here. We're going to make sure it's selected on HTML. And then for the title here, I'm just going to say, let's make it homework 1. Yeah, go ahead and do that. If I hit OK here, what you should see pop up is a new window like this, a new tab anyway, with your blank Markdown document. When I say blank, it's already pre-filled with a bunch of stuff, right? Okay, so what you're going to get is you're going to get the title you put in there, the title you put in, it's going to default to showing today's date. That's perfectly fine for our purposes. And it's going to say output HTML document. Okay? At this point, before you insert any other code, you mess with anything, I would recommend you go up and press knit. Press knit here, it's going to ask you to save it somewhere. You can put this thing wherever you want. I would recommend that you have a dedicated folder for this class, and then perhaps folders for each homework assignment. In this particular case, I'm really just going to dump it in my ignore folder right here and here. I'm just going to say, actually, I think I'll put it in the lab folder, homework 1. You save it, and as soon as you save it, if you press knit, it's going to pop open the knitted document. So here's a question I missed here in chat. I missed the answer in class. If we don't have author or date, what is the edit we need to make? So you see, do you see only title up here? No author date, but you see title and output?
Yes.
Oh, interesting. I'm not actually sure. You could add them manually. But typically you ought to see, and did you input them here in the dialog when you created the document?
Did I input what? Oh, you know what? Maybe I didn't.
If you leave them blank, it might. I'm actually curious. I've never seen that before. So let's see what happens if I leave them blank.
Okay.
Yeah, it doesn't produce them if you leave them blank. So, okay, maybe that's what it is. I've never actually done that before. So now I know. Okay. Yeah. So we have this document. And if you press knit on it and you save it somewhere, you will get this knitted sort of HTML document. If you want to see it in your browser, it's going to look the same, but you could click open in browser here. I could drag it over onto this monitor, and you're going to see your R Markdown document. All right. So this has all of the text and the code that was displayed in the default document. It just sort of generates this little HTML web page. If you put this thing online anywhere, like on maybe you have a GitHub repo or something, and people browse to it online, it'll look just like this to them, including with the images and everything. So this is a cool way to share documents. Literally any person who has a computer or a phone can open up, right? PDFs are kind of annoying on some devices, but this can open up. You can open up on your phone. Great. Here's a question. If we're not showing the results for 2 things, structure and summary, then can we put it in one chunk, not showing the code and result? Yep. Or is it better divided in 2 chunks, both not showing the code and result? Whatever makes sense for you and the purpose. So we can play around with it. The thing with both structure and summary is you usually use those commands specifically to see an output. So if you're not generating any output at all, you might not even use those commands, structure and summary. Those are usually ones we would use to take a quick look at our data set or something and be like, well, what are these data about? Which I will show in a minute with our Swiss data set. Okay. So you can close this window. So this window here that pops open when you knit your document, what this is this is not like just displaying a preview or something. This is actually opened up the file on your computer it is generated. If you browse to the location, so if I go into my folder, sorry, again, it's very small, CSSS508, I put it in my ignore folder, my labs, you'll actually see the file we're currently working on, the RMD, is this homework 1 file. But by knitting it, it's generated another file with the same or basically the same name. That's an HTML file. If I double click on that, it's going to open it. We're going to see the exact same thing. So by knitting your documents, it produces the HTML or PDF or Word file on your computer. And wherever your RMD document is, it's going to produce that file in that same directory. So if you need to track down your file, it's wherever you saved your RMD. Okay. And something I've noticed in recent years is that people are getting progressively less familiar over time with how file structures work on computers because it's becoming less relevant to using them. A lot of people use devices where you don't directly interact with the file structure anymore. If you need to know how to navigate and work with folders and directories on computers better, let me know, and I'm happy to give tutorials and sort of tracking things down on your computer. Okay, so we got this document. It looks like a thing. So what we're going to do here is I'm going to immediately delete everything below that YAML header. Leave intact the 3 little hyphens here, 3 little dashes, because they mark off this YAML header, but nothing else is necessary. Oh, so I missed this question here. I'm not used to having my chat this far away from me because I'm usually at my desktop. I'm not sure why, but after I knit my document or save it, it changes the way my console looks and isn't as editable anymore. This is just an issue with your Studio. Automatically sets to the terminal tab. Yeah, it's most likely what it's doing is not necessarily the terminal tab, but maybe the R Markdown tab over here. So yeah, this R Markdown tab here is essentially giving a status readout of the progress of turning this document, the RMD document, into the final file. This stuff can be useful for diagnostics or for really long files that take a long time to knit. This thing is so fast, you probably didn't really get to see all the stuff, but basically it'll show you what sections of the document it's currently in and is running code, its overall progress through the document. And then at the end, you're going to get something like this. You're like, what is this? This is the actual system command it makes to the terminal on your computer to turn the document into the final HTML output. This is a call to Pandoc, which you don't need to know unless you run into issues. Okay. And then it will say something like output created homework 1.html. If it's still up in this R Markdown pane, just go ahead and go back to console and you're back where you were. Okay. Okay, so we got this blank nothing canvas here, and let's add some stuff to it. So what I said for this homework is that we would use the Swiss data set. The Swiss data set is a really simple built-in data set with some numeric variables. It's good for kind of exploring univariate or bivariate relationships and stuff, do whatever you want. If you've taken some statistical training, maybe you'll run a regression model or something. I don't expect you know any of that stuff. Okay, so typically what we would do is if we want to do any kind of put any kind of R code in our document that's not inline R code, we typically need a chunk. So if I hit, I think it's Control Alt or Control Shift I. Control Alt I for me. On a Mac, it's probably Command Option or Command, what's the other one? Command Option I. Beautiful. So here's a question. When the homework asks for R output, what does that mean? And for the pairwise plot, are we expected to explain in terms of certain clear correlations, positive, negative between two variables? No, I don't expect in this class you know what a correlation is, so you're not required to do something like that. But you could say something like, these things look like one goes up when the other one goes down or whatever, but you don't have to say that. You could literally, if you do a pair, pairs plot, you don't even have to do a pairs plot. That'd be more like if it's something you want to talk about. I generally don't really care too much. Just, pick out something you think might be interesting, look in there and comment on it, however you feel comfortable. Okay. So when it says what it asks for R output, what I mean by R output would be, let's say I do something like this. So let's say I just printed my Swiss data set. If I type Swiss right here and I hit Control Enter, it would display the Swiss data set up in my document like this. This is functionality called an R notebook. Your R Markdown documents function also with notebooks. If you run code up into chunks, typically appear under the chunk. Some of you, it might appear down here in the console setting in your R Studio and set display in here so it's easier to show y'all what's going on. It's up in the console, it's the same thing. Type Swiss down here, you would exact same output that's in the document in the console. It's the same thing. Anyway, what I mean by R output or R output in your document is, I don't want your document to look like this. This is the raw output in the document. If I just Swiss, it's just going to dump the data set into raw output that just looks like what you see in your console down there. I instead just say, basically, you probably shouldn't put the entire data set in, but as an example, you could turn it into a prettier table. So I mentioned before about loading packages. I said about before, but in lecture rather, I talked about loading packages. So if you've installed Pandoc on your computer, if you haven't, let me remind you how to do that. So if you want to install a package, if you don't have Pandoc on your computer, you can say install.packages, Pandoc. Now notice I do install.packages in the console down here, not in my RMD. I'll show you what happens. So first I'll tell you this. What this is saying down here, install.packages Pandoc, this is actually telling you exactly what it's doing. It's saying, I am trying an online URL to go search for this package. The URL it's trying is it's going to go over to cran.rstudio because that's where I've set my cran mirror. There's a million different places that store R packages. It doesn't matter which one you're at. It goes down here. It looks for my current version of R, which is a 4.0 derivative, 4.04, I think in the case. And then it says it's going to search for Pandoc, this zip file, attempt to download it and install it. It does that. It does things like it's a 1.0 package, it downloaded it, successfully unpacked. The MD5 sum, important, is just a checksum to it's the correct file, and some hackers dropped in some inappropriate to it. It downloads, tells you where the temporary file is, and it installs it. I can now use this package. If I want to use it in my document, you want to put library Pandoc in the Markdown document. So you install packages down in the console, you load libraries up here in the document. If you don't load the library in the document, you won't be able to use functions in it later. Now, if I knit, that library command isn't going to do anything. It loads it, but it doesn't run anything in the process. It's just something that's there loading it so that the commands from that package lurk waiting to be used. In contrast, if I try and say install.packages up here and try and knit, are going to get angry at me. So this is saying here, I'm processing this file, I'm quitting due to something I see in lines 9 through 10. Well, line 9 is install.packages right here, and it's going to say error. Trying to use cran without setting a mirror is going to give me this error here. What this is going on here is that basically some default settings required to run install.packages don't exist in our Markdown doc. This is actually sort of a way to halt and prevent you from installing packages in your document. You shouldn't install packages in a document like this. Do them in the console, but load them in the document. Unfortunately, those are sort of two separate things, but then again, it's good you don't have to reinstall them every time. Is that clear on the difference between installing and loading the packages? It's really the difference between like installing RStudio versus like opening up the font, opening up the program. This is essentially opening up this package so that you can use stuff in it. Now that Pander's there, I can take that Swiss data set, which looks like the thing below. If I wrap it in Pander, all it's going to do, I'll run the library, then that. It's the same output. But what it's done is it has converted the output of that Swiss, and I'll show you the original thing before. The original thing output looked like this. It's converted it into Markdown code. These dashes here are going to make a horizontal bar. This is just an open space right here. It's going to bold these names down here, and then it's just going to display the values otherwise the same. If I knit this document, it's going to look like this. So instead of looking like garbage output straight from Rs console, it just looks like the exact same thing, slightly pretty with some bold text and some nice horizontal lines and things. So the entire purpose of Pander is just to dress up your output so it doesn't look like it's just a dump straight into your console. That's all it does. Sense? And you can do Pander with most things running on. It's pretty flexible. Questions about that?
Yeah. For the tables, are we expected to put like the heading of the tables or is it okay just how it's shown now?
It's okay now, and then this is basics, you know. Would say that if you're interested in that, experiment with it, see what happens. I think Pander for a data frame, you something like let's see what happens. I think it's caption. Throw it at the top. Does it throw it at the bottom? Yeah, now there's a test caption. Woo! Okay. So there is some functionality like captions to a table. If you want to mess with something like that, go for it. You don't have.
Do you know why Pander is called Pander?
Yeah, actually. So Pander's essentially something for our output and generating Pandoc friendly markdown. So Pandoc is the all document piece of software that lurks all the R markdown documents to enable them to be converted into other formats like PDF, HTML, and stuff like that. Pander specifically for talking or producing stuff to be digested by Pandoc. So a lot of our funny little names like that. That's just it. It's based on the Pandoc, which is a funny package, which is not an R package, universal. Just a piece of software, but it's funny. It's the all document. Anyway, so something to note in this. Oh, here we go. Here's it. I'm getting an error when you install Pander that says our tools is with packages but it's not currently installed. Download and install the appropriate version before proceeding. And I guess yes. So what I would actually think is typically what that error is indicating to install the package from source rather than a binary. So normally, if you ask to install a package, it might bring up a little pop-up when I think of something that might give me a similar window, or not a window, but a dialogue or dialogue in your column. It'll usually say something like press 0, 1, 2, or 3 to do different things. One of the options is to install binary, the other is to install from source. Would you like to install from source? Yes. You select yes. Installing from source requires that your computer have a compiler, usually for C++, built into your C or C++ built in, so that it can compile that code, machine-readable code. By saying, yes, I would like to install from source, your computer went, the compiler didn't have it. So tools use that compilation for Windows. To install and prep R through your computer, if you want to be able to install packages, of course, which is not required, but you can, and I like to do it. You can go to the website, and there's actually a enabling compilation packages entry under important links. You go here, and I've got instructions on how to set for Mac or Windows machine to enable compilation of packages. Steps are a little bit different. You're on Windows judging from that error. So essentially what you'll do is you will browse to the page. You'll download and install the 64-bit RTools installer. You'll follow the instructions, but then you'll go back to the page and there's a couple extra steps you have to do, which is essentially this thing about sys.which_make. If I take this code and run it in my RStudio, I see something that looks like this. C/user, cclan, whatever, it has a location defined as make.exe. Make.exe is a piece of software that essentially assembles other pieces of software. You have to be able to find make. If you do sys.which_make and you don't get a result, you don't have your compiler set up on the computer, you got to file the instructions back on that page. It's kind of a pain in the ass, but once you've done it once, you know how to do it in the future. Okay, here's a question here. So our output just means in our knitted files having good looking tables and graphs be a pander. Yes, yeah, that is exactly it. Now. Oh, is my audio cutting out? Yeah, I've been having an issue. I'm connected to my damn Wi-Fi extender again, and I keep disable its connection to my desktop. Let me unplug it real quick. Okay, should have popped to the correct internet connection automatically. Okay, so yeah, I have a ludicrously powerful Wi-Fi extender all the way across the house. So my computer insists on connecting to it badly instead of connecting to the router, which is 7 feet away right there. So this is technology. Okay. Yeah, that's Breon's dead on that one. So if you want to know what these variables are in the Swiss data set you're going to work with, !Swiss. We'll bring up a help file and it will tell you. So for instance, the question is, what are the units of fertility? Fertility is IG, a common standardized fertility measure. Yep. How is it measured specifically? Demographic measure. You could, in fact, would probably have to Google this measure and look online because I don't even remember what it is. I don't know. Do you know, Brianna? How's your demographic training? Yeah, I have no idea what that is. It's probably something like relative to replacement fertility or, let me go look. It's IG. I'm getting all this annoying stuff. Tell me, okay, fine. Be that way. National averages for marital fertility. Person married. IG. What's IG? Marital fertility. Okay. How is marital fertility measured? Let me guess, I don't have access to it. Oh, no, I do. See, if you ask me to go on tangents, I will do them, even if it requires going on Google Scholar and looking stuff up. You got me. Okay. How is marital fertility measured?
I found a source. I just put it in the chat.
Ratio of the number of births occurring to married women to the maximum number of children that married women might. Okay. Yeah, so that's essentially, that makes sense. Ratio compared to maximum fertility. So it's like divide the actual observed marital fertility by like Hutterite fertility or something like that. Yeah. Okay. Good to know. So it's a ratio. So based on the fact that it's a ratio, we would expect fertility to be something that looks like a percentage. So something that should range, you know, if they're getting close to 100% like they are in this particular canton of Switzerland here, that's getting really close to like maximum possible fertility. You would expect that to be a highly agricultural place, I would imagine. So agriculture 84.6 kind of makes sense to me. Probably super Catholic. Where's the Catholic one? Catholic. Yeah, 99.46% Catholic. Demography. Okay. So, yeah. Okay. No, got some stuff there. So other things I'll quickly show you just because you're going to want to know how to do these things is if I knit this document, still with my big ugly display all the data table here, of course, I have the code here, right? It says library Pander, it says Pander Swiss. Even if I wanted to just show everybody the entire data set and table, which I probably don't want to do, I probably don't want to show them all this code up here. And one of the instructions for this homework is try and hide your raw code, right? So this is cleaned up output that looks nice. This is still raw, kind of ugly code. Unless you're specifically giving people examples of how to run and generate some code for something, you probably want to hide it. If we want to hide it, that is something called a chunk option. What we can do is I can go up to this chunk header. This is the header for a chunk. If I add after the R right there, a comma, I can then add things like echo equals false. So this says right here, I want to turn off the echo option. Echo defaults to true, and echo says, show the R code, echo the R code out into my document. If I say instead, do not echo my R code, and I knit it, I get the same table, but the output is suppressed. So if you're producing a journal article, a memo for your advisor, any of that kind of stuff, sometimes even certain homeworks and classes, and you want to suppress your code, echo equals false will get rid of it. If you want, you can do the opposite, which is to display all of that code and then say something like eval equals false will prevent the code from being run. If I knit this, there's no, it doesn't run the code, but it displays it. Another option to do would be to run the code, but not show its results. Not include, but results equals. You have options, markup as is, hold and hide. Hide will suppress all the output. It'll still run the commands, it just won't show their results. Sometimes you want to run something and not have the output of it actually shown in the console. Results equals hide will do that, not the console, but in the document itself. There's a million of these chunk options. If I go here, I can scroll through and you can see there's a ton of these different arguments you can give it to do things. If you want to know what they are, it really comes down to thinking to yourself, okay, I got this thing I want to do, and then looking in the documentation. Nobody's going to memorize all this stuff. Okay. So I think that's the main stuff I wanted to cover there. What kind of things do folks want to do? Any questions? Fancy stuff you want to do? Easy things you want to do? Something broken?
I have
Oh, go ahead.
oh, sorry.
Mm.
Oh, I have a question on like the code.
Mhm.
Like, should our code look really similar to a lecture's? Because I feel like I'm borrowing a lot of code and like our code is supposed to be original or not.
What does original mean in the world of programming? I think is the real sort of thing. So this is the thing, right? It doesn't actually really matter that much. If you accomplish the task you want to get done, then you're using the right code for it, so long as it gets done in the time span, that you want to get it done on. Hopefully your document's not operating over like geological time. But if you can get the task done, that's fine. So using code that you find, that you copy it, that's perfectly fine. In fact, that's the way most people, especially like I'm basically self-taught. I learned how to make these things work the way they want them to by when I run into something I truly, I can't solve myself, and something that doesn't immediately occur to me, I go and look for solutions and then I modify them for my purposes. And that's basically how everyone operates, including people who are professional software developers, who will go and hunt down things like, well, I need a solution for this thing. Literally every problem you will ever encounter in your program has been solved by somebody probably 30 years ago, algorithmically or longer, right? Reinventing the wheel is just unnecessary. And if you need efficiency, you really don't want to reinvent the wheel. You want to use somebody's fast implementation of something. Now, you don't worry about it. If you're worried about something, cite people's code. I do it all the time. I mean, I have scripts. I don't want to swap between things, but if I take a solution from Stack Overflow, in my comments in my script, I put a link back to the Stack Overflow and I name the user. Citation, I'm done, right? If I'm using somebody's code extensively, I may actually cite them in my references section in like the paper or something like that. Give attributions, but now just, use other people's code rampantly. I mean, it's essentially what packages are in here is somebody else wrote a bunch of code so that you can use it conveniently. Use my stuff all the time. Steal it all. Use it for your purpose. There's another question.
I was just going to ask, I've had R downloaded since last quarter at some point, and I can't figure out how to update it to the new version. I know you said uninstall and install, and there were arguments online when I was trying to figure it out. Is there an easy way to just get it updated?
So you don't so much update R as you download a new version and just install it. And so every version by default goes into its own folder on the computer. I highly recommend just installing a new version and then reinstalling the packages that you want to use, because that's sort of a way to do some spring cleaning. So it cleans out all the stuff you're not using so you don't end up with it. And then what I usually do is I install a new version of R, I keep the previous version, and then like as I install, I keep one previous version just in case something catastrophic goes wrong. I've never had an R installed. I've never had to roll back to the previous version of R. It's basically everything you have to do. But just in case, I like to keep the previous version. I delete all the prior ones. And since R updates typically 4 times a year, every season, I basically clean all my packages out, reinstall fresh. And it's just a good practice because things update, things change.
Right. I guess I'm just surprised that it's not within it already, because it does update so often. I'm already getting like warnings that some package was built for 4.04, and I was like, wow, it's already useless. Yeah. Okay. Cool.
Well, and there's very few changes, so you don't really get hurt by not jumping to the new version. Typically, big versions, yes, like jumping from a 3 point anything to 4 is huge, and you got to do that. But after that, it's like these intermittent ones. The differences are minuscule. Yeah, it's not really a big deal. There is a package called like install R package, which does updating and copies your packages over and stuff like that. I recommend not using it because it can occasionally break and just fuck everything up. And it's best to, I just say, install from scratch. And you get used to it. I mean, God, how many times have I probably installed R installs? Sometimes I forget to delete the old ones. I might just went back and I had like literally 7 versions all stacked up on my computer, eating up memory, and clear it out. I cleared like 2 gigs off my drive.
Okay.
Spring cleaning. Anything else? Yeah, I'm happy to field. It doesn't have to be homework specific, any of that kind of stuff. I'm perfectly happy to answer any of these questions. And this goes for every lab. So yeah. But if you want something specific, you want to know how to do something, make a table, make a graph, something like that, I can do it. We look at Catholic versus Protestant and fertility for fun. Yes, that is my kind of fun too. Okay, so what I'm going to do here, something I recommend doing is have a chunk at the top of your markdown where you load your data and you load your packages. And this one is just a hidden chunk and that doesn't display in the document. So to do that, I'm going to say include equals false. Include equals false is a special setup chunk option up here. What it does is it runs all the code in here, but it suppresses every kind of output it could possibly generate, all messages, all errors, all that kind of stuff. It's good when you load packages to do include equals false because some packages like to give you startup messages, information and stuff you don't want in your document. So I'm going to have this chunk up here and I could load other packages, but for this purpose, I'm not going to. I might also, if you had a data file you want to read in, I might read it in up here. I'm going to put data Swiss here. It's technically not necessary, but if I go data Swiss and run it, it'll show up here in my environment up here, which I could then make it display and browse around here. I could see that. Anyway, so what we want to do here is we want to look at Catholic versus Protestant and fertility for fun. So what we'll do is we got a couple options here, okay? We could look at this in a tabular way. We could look at this in a graphical way. So I haven't introduced ggplot, so I'm not going to show you any ggplot stuff to do. And I haven't introduced dplyr and the rest of the tidyverse stuff. So I'm not going to show you that. I will show you BaseR ways to break these up and tabulate it. So there's a question here. Isn't there a way to set chunk default options? Yes, there is. It is, if I create a new markdown really fast, I can get that. Okay, options chunk set echo equals true. Okay. Yeah, if you wanted to make it so every chunk in your document has echo equals false set, you could do this. This is basically options chunk, set a particular option for all chunks, echo equals false. This will set every chunk in your document to be false by default. You could overwrite them by going, override that by going echo equals true, but by default, they'll all be false. So yeah. And this little colon thing says go into the knitter package and then find something called options chunk. Okay, we'll see this operator some more times in this term. Anyway, so I got this new chunk here. So what we want to do is we want to look at Catholic versus Protestant levels of fertility. So we might just do that in a tabular fashion. Let's say we want to do something like, I want to look at just what are their mean values. So what would be like mean Swiss. Remember how to get a specific variable in a data set? Do you remember that from lecture? If I want to go to the Swiss data set and get
$sign.
$, exactly. So I can get $, fertility. If I run this, the overall average of fertility in the data set is 70.14. Okay. So what I want to do though is I want to get the mean specifically for Catholic and the mean specifically for Protestant. A clunky way to do that would be to do something like this. Let's do Swiss fertility is what I want to get a mean, but I only want it for the ones that have a high value of Catholic. Okay, I'm going to look at Catholic really quick. Let's look at the mean of Catholic is 41. Okay, so let's look at what is the mean level of fertility for the bottom half of the distribution of Catholics. So let's look at Swiss fertility when Swiss Catholic is less than 41.14. This is going to give us the entire column of fertility for only those cantons of Switzerland whose level of Catholic is below this number. So what this thing over here is, this is a logical statement, which is something we're going to talk a lot about in the next 2 weeks. This bracket is a subsetting operator. This is a way to say, go into this column and then select only the observations where some particular statement holds. We're going to see these a ton, well, not a ton, we're going to see them a little bit here on Wednesday and then a ton on next week. So I'm not going to dwell on it too much. I could then get the mean of this by wrapping it like that. That would be the mean for the low Catholic. I could then get the mean for the high Catholic places, and it would look something like that. I could do these both simultaneously. I could do something like, well, actually, the easiest way to do this would be t-test. Well, I'd have to dichotomize that, wouldn't I? Would be the nicest way to do that. Yeah, a better way would actually probably be, let's say, let's take, try to do these clunky ways to avoid showing you the elegant but possibly unpleasant ways to do this. I guess I could actually t-apply over this, couldn't I? Let's see. Yeah, that'll work. So what I've done here is something that is very advanced, actually. You're not going to see doing commands like this until week 7, I think. But basically, I said here, I've got this Swiss fertility vector. I want to do something to it. What I want to do to it is I want to get its mean, but I don't want a single value of the mean. Instead, I want to divide this vector up based on whether or not it is above this particular threshold of 41.14. It's going to get the mean for everything above this threshold and then the mean for everything below that threshold. So for cantons in Switzerland, whose value of Catholic is above 41.14, their fertility is this. For the ones below that threshold, it's 67. Okay, this is a complex command, t-apply. It's a way to perform iterative operations. But it's an example of how to do that sort of in one line without resorting to the pretty tidyverse stuff we're going to learn starting this week, actually. And it is identical, of course, to if I combined together these two statements are identical. Okay. Any other fun questions?
Could you explain what the factor function does again? I missed that.
Yeah, I mean, let me check and verify I actually need it for this t-apply. Okay, I don't. Okay, so t-apply is a function which applies a particular function like mean over a factor, but it looks like it coerces it to a factor to begin with. A factor is a type of categorical data that has a discrete number of levels. We're going to spend a lot of time on factors later in the term, but basically factors are how R stores categorical data with a limited number of levels. It's kind of like, it's not exactly the same as text, but it kind of is. Factors add one major thing over raw text, which is the ability to have a reference level, which if you use a regression model ends up being the default category for your dummy variables, which it automatically generates. Does some other stuff. Any other fun stuff? And it can be very simple too, or going back to redo something I did before. I don't mind going back. You got me here until 5:20 and I will answer any question.
Could you maybe just demonstrate how we could take the results we just got on Catholic fertility and put that in inline text?
Sure. Okay. So what would be the best way to do that? So probably you'd want to do something like, say, okay. Sterility for Catholic is, I'm going to say R low cath. Low cath is a thing that I'm going to create. I'm going to go up here and I'm going to say, okay, low cath, I'm going to assign to that this here, and that'll probably do the job. It's not going to be rounded, so if I knit this here, I'll explain this too once I display it. So what I have done here, right, you'll notice it's not showing the code chunk up here because I'd set that default echo to false up here at the top. So basically it says here, the average fertility for cantons below the mean percentage Catholic is 67 point blah, 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 way too many decimals of precision. Because what it's done is it's calculated it up here in the chunk, assigned it to low Cath, and then just displayed it down here with this inline operation I've got right here. Well, I could do something like, let's round that so it's not absurdly precise. I'm going to round it to 1 digit, knit, and now the text says 67.3. I could then say, and then I'm just going to say literally the exact same code. Hi, Cath. Flip the operator. Knit it. Glorious. The average fertility for those above the mean is 74.3. So this is something where this operation is big enough that I didn't want to throw the entire thing in line. So I did the actual calculation up above it, and then I called on the object I generated. It's easier than putting this all in the text. I could put all in the text, but it'd be a pain. So Brian's question down here, why does your assignment operator turn into an arrow? Dark magic, Brian, dark magic. So the way I have that set up is I have a font, Code Retina, here, which permits ligatures. And then I have ligatures turned on somewhere. Where's ligatures turned on? Console code. Could have sworn it was in display. Where are ligatures? Well, Google ligatures, and that will get it for you. Yeah, they're just ligatures. Does it for a lot of stuff too. So for instance, if I do something like, oh, what are good examples? If I do that, you'll notice it actually changes to, instead of being 2 separate ones, it's turned into a combined one. If I do exclamation point equals, it turns into a not equal sign. Ligatures are nice and make your code a little bit more readable. Some fonts support it. I really like them. It can be confusing to students watching me, but I refuse to turn them off because they're very nice. Makes it easier to see things at a glance and scroll around. They also do it for things like less than and equal than, greater than and equal.
Did you have to download that font?
Yeah, Code is one of the most common ones. There's a few out there too that other people like to use, but I just went and downloaded it. Test science going too far. Yes.
Is that through R, or do you have to go on the browser?
It's just, it uses your system fonts. So just go online and search, like literally we just Google Code. You'll find it. Free monospace font, and you see it has with programming ligatures. Yeah, and you can just grab it off of its GitHub. Yeah, it's a free font. It's really commonly used by programs. There's a few of those. There's always, every year, there's a different in vogue font, and Code was really popular like 2 years ago, and I still like it, and I haven't moved off, but everybody else is using some other new fancy thing, as if the font makes a big difference.
So you download that onto your computer, and then R automatically picks it up?
Yeah, every system font you've got, if you go to appearance and available editor font, it will show every monospaced font on your computer. Every fixed width font, I think. Yeah. Oh yeah, and it does make the 0 and that different too in this font. So for instance, if you see zeros look like that and O's look like that. So Code is also really nice for that, for the quick difference between O and 0. Also between like L and 1 and capital L and capital I all look completely different, which is actually really nice if you're writing code.
Would you be able to explain a little bit about how GitHub works? I hear it all the time. I know like some general, but I'm curious about GitHub. Yeah,
okay, so this is a big thing. So GitHub is just a place for hosting Git repositories. So a Git repository is Git is a version control system. Version control systems are basically just a way of documenting all of the changes ever made to a bunch of files in a project. All they do is anytime you make some sort of an edit. So as an example of this, I mean, honestly, I can just go to my, go to this class. So we got something like this, and zoom into it a little bit bigger. Okay, so if you want to know every edit I have ever made to this class since I started teaching it, since I created it, you can see I have made 644 commits. That means I have edited the content for this class 644 times. If I click on that, you can see every change I have ever made to any document in my project. If I click update index.md, you can see last week when I changed the link for the lecture slides on it to the one from the lecture I just recorded. All of the updates, so this is the text that was deleted, this is the text that replaced it. It does that for literally everything you ever do in an entire project. So for instance, you can see when I'm updating dates of things, I'm modifying little pieces of code. This is every change made to the document, every file, everything. So you could basically with Git reconstruct every edit ever made to any document in the folder, going back to its creation.
Is this done automatically, or do you have to manually update? So it's linked to R. When you change things on R, it uploads to GitHub automatic.
So the way it works is if you have it set up, I actually don't use RStudio's Git tracker. It is active. Mine is active, but I don't use it. I instead do this with the GitHub's desktop application because it offers a couple of features that are useful. But basically, I have a little application here, which I can go through all of the different repositories on my computer. And if I make any kind of edits to any document in this repository, so for instance, if I go to the syllabus, let's add a space right here that no one will ever notice. It immediately pops up that you've made an edit to this. I've added a space in that particular spot. It tracks it. And then if I push this, if I commit to master, it will update the things on the repository. The website will re-render with that extra space little there. It takes a few minutes. Everything synchronizes, and then anyone following this repository can also synchronize those changes too. So version control comes from software development to allow an unlimited number of people to simultaneously work on the same files and documents and things to merge all their changes. So if you're working with a lot of people all operating on the same stuff, this allows them to all do that and merge all their changes and track every change that's ever made. So if somebody breaks something 6 months down the line, you realize it, you can go back, find that change and revert it non-destructively. It's incredibly useful for software development.
Yeah, that's, I've heard about it in the terms of collaboration, basically with people online. But is it used? It's used for more types of code than just RStudio. Is that correct?
It's actually totally agnostic. You can use it for text documents and writing. You can use it for a Word document. I mean, literally any file on your computer. So it actually synchronizes folders on your computer. So basically, my GitHub repository. So this is the CSSS508 folder on my computer where this class is located. If I go to my GitHub repo, you'll actually see these are the exact same folders here and there because it's actually just mirrored this folder onto GitHub. So it's basically kind of, it's reminiscent in some ways of something like Dropbox or OneDrive, and it's sort of mirroring things like that, but it also keeps in it a consistent record of everything that's ever happened to any file in there, which means even if you delete something, it's never truly gone. It's reversible. Everything is reversible. Nothing is ever lost. This is very good for reproducible research because it means you can document every decision that was ever made in the entire existence of the project going back to its inception, which is terrifying to some people in terms of like everything laid bare. But it's very good for like general practices. These are the kind of software development practices that the sciences have been taking up really recently. Some sciences have done a much better job than others with it. Yeah, this is already in chat. My hackathon team used Python, and GitHub was a godsend since we're in different locations. A little tricky to set up. Oh, it's not just tricky to set up, it's a pain in the ass to use. GitHub is like, Git is one of those things where it's an arcane, bizarre thing. most of the time it works fine, but when it breaks, it's just like, oh, it just destroys your life briefly. But it's so useful and powerful, and it's better than every other version control system, so it's what we use. But it's amazing. Yeah, if you have people working in different locations, yeah, it's just, there's nothing like it. It's so much better than every other option that you've got. And you can have, hundreds of people collaborating on the same project and synchronize all their stuff basically without problems. And the thing is most R packages out there, if I go like dplyr is a package we're going to spend a lot of time on in this class. Its GitHub is right here, and you can see they like track current bugs in the software. People chat about it, try and figure out solutions. People put up requests to upload fixes to things, and then you can basically accept and they'll merge them in to fix it. It's how all open source development basically happens in the R world. It's all tends to be going over some Git repository. GitHub is just one place to store them, and it's one of the most common ones. It's not the only one. Git itself is a piece of software for the actual version control, written by Linus Torvalds, the author of Linux. So it's actually was created to be the backbone for the Linux developing the Linux operating system, which of course has tens of thousands of active developers on it. Thus, it can manage that sort of backend. Okay, yeah, Git is a very useful skill. If you're going to work anywhere outside of pure academia, Git is incredibly valuable to have. Academics are a little slow on the uptake. So here's a question in the chat. Could you go over how to round 2 decimal points when calculating mean or median? Absolutely. It's very easy. So what I did here is I had this original code, like stuff like this. I'll just paste this back here. This one here is a arbitrarily long decimal number, 67.33571. If I take this exact same command and say, well, let's round it to 2 digits, it just truncates it to 2 digits. Technically, it's not truncated, it actually does a proper rounding job. That will round it. So that'd be how you do that. If that makes sense. You just huck whatever you want rounded into that, and it will do it. And yeah, that's the other way you can do it. I used a nested line of code with rounding front and then median. Oh, that's exactly what I just did. Yeah, you could also do something like, if you want to do it as stages, you could be like, 1. You could also do something like that. You could say like, oh, well, first I want to get the mean of this thing and assign it there, and then I'm going to take that thing and round it and replace it. You could always do these things in steps too if you want, because the code runs sequentially, so it'll just override it with the rounded one, whatever makes the most sense to you. Later on, we'll show you fancy ways to do things like, I would instead say something like, get oh, I actually want the mean of it first. You do stuff like that. We'll talk about piping things starting this week, which is an easier way to read code, because it's sort of, I start with a Swiss data set, grab a variable from it, calculate its mean, and then round it to 1 digit. Reading left to right is easier than reading these bizarre inside to out statements. So if this right here looks like weird garbage to you, don't worry, we're not going to write things like this for very long. Any other questions? Coffee, what can't you do? Double check that I missed anything. Okay. Anybody want to see any plots or anything? Want to do something like that? More inline stuff, messing with text.
Sure. What other plots? So I ran a pairwise plot because that was what was shown in the lecture, but I was wondering, what are other simple plots that we could do?
Tons of easy stuff. So really easy stuff on it. I mean, Pairwise is basically pairwise scatter plots, and scatter plots are super easy to do. So I could do something like, say, plot like here's a scatter plot of fertility on Catholic, which is what your pairwise plot is, just a lot of these things. You can do something like that. But we could instead, we don't have any categorical variables in here, so the like box plot would be kind of arbitrary. What other good ones would be? Histograms are very easy. I mean, I kind of showed histograms before, but I could say like histogram. Does histogram take a data argument? I don't think it does. No, it doesn't. Okay. So I could say Swiss fertility. Give yourself a histogram showing you the distribution of it. Not fairly normal. It's kind of got a nice arc to it, not for many super low fertility places. There's a lot of BASAR plots. I mean, there's things like there's box plots in BASAR. Yep, there's a box plot, but I don't have categorical variables, so I guess I could do something like let's do box plot. Why is numeric split into groups according to the grouping variable usually a factor? Let's do let's add a categorical variable Swiss. Let's go. Cath is going to be equal to Swiss Catholic greater than 1. Then I'm going to say, let's look at fertility, high Cath, that equals Swiss. So what I did here is this was like some quick code to generate a new variable in my data set. I basically want a variable that takes the value of true when Swiss Catholic is above 41 and false otherwise. Logical statements, we'll cover these on Wednesday. And then I said, let's make a box plot. So a box plot is going to plot fertility. It's going to show its mean, and then I forget what range it'll show by default. It's a box and whisker plot. It kind of shows where average values are in the distribution, and kind of also at the same time shows its skew, stratified on high Catholic. So these are the mean value of fertility for low Catholic countries, or cantons rather, the value of fertility for high Catholic cantons. It also shows when there's a few outliers in a particular distribution like that. It's a simple box and whisker plot, kind of a common old school style plot. But there's a lot of other plots out there. Kind of graphics, there's probably a million of them. Contour plots, don't have anything good I can do in a contour plot.
Yeah, I see legend on there. So at least for my pairwise one, I want to show that the sides are percentages because that's not immediately clear from the graph.
Mhm.
So how can we add axes, like I guess titles that have their units?
Yeah, that's a good question. And I'm not an expert on this pairs function, so let's take a quick look. Adding units might be difficult to this, but I accept all challenges. Because it might have to require some weird step getting to the panel features. Let's see. Okay. Ooh, this will be a challenging one, I bet. Okay. So how would I add unit labels to the axes of every panel? Wow. That's a really good question. Yeah, I don't use this function very often, so I've never had. So I'll show you my process for this. Add labels to pairs plot R. Okay. How do I add labels? Look at Stack Overflow. Okay, well, that's not the type of labels that I want. Ah, that's fun. Not what I'm after, but I want axis. So let me go back, add axis labels to pairs plot are. Oh, pairs, changing labels in pair plot. Okay. How would I do that? No, the select variables, labels and title. Okay, let me see. Diagonal labels by group. Oh, holy crap, that's cool. All kinds of weird stuff. Okay, then they go straight to GG pairs so it's easier to work with. Labels on the side and bottom instead of diagonal. Yeah, I have no idea.
Or is there a way to just like add a comment down, I guess, down by the title of the plot and then just make a quick note saying that all the units are in?
Oh yeah, that'd be much easier. Yeah. So what I could do for this is you could probably, does it take a, yeah, let's see. I'm changing on the main panel. Labels. Yeah, it doesn't take a, I mean, it takes a main title one, just almost assuredly. But doesn't, I don't think it takes a subtitle, does it? These primitive old base R functions tend to have limited things. Let me take, okay, it does take that, but it probably doesn't take, no, take a subtitle. No, subtitles not the graphics parameter. Let me see, is there, do you take a subtitle? Oh, it does take a subtitle, just with sub. Oh shit. I learn something new every day. Theoretically, there should be some text there, but I don't see it. Knit you and see what happens. If there's some text, I sure don't see it. Let me look. I want to see my dissertation chapter. Huh. Oh, they're using the title call to do that. Okay, we can do that. So the way base R plots work, which is kind of weird, is that you can chain together multiple functions just by calling them one after another. But if you don't run them simultaneously, you won't get the result you want. So we got to highlight both of them, do that, and now there's some text down at the bottom. If we knit this document, it will have some text down at the bottom. And so you could do something like that with subtitle and write like all are in percentages or proportions. So that would probably do what you want.
I see. So I'll just have one line of code that has like actually plotting the seeing of the colors of the like other stuff, and then I'll have one with title.
Yeah, basically. So you could say here title, and then you could actually it would be like main equals some top title sub. If you're running both at once, that should be a title up top and a title. Yeah, title up top and the subtitle down below, which is essentially a caption.
Right. Sounds good.
Yeah. Okay. Yeah, later we're going to get to the GG plots, which is what I actually use on a daily basis. And I tend to remember how to do everything. And actually labeling every single one of these like things on the side would actually also be probably a pain that way, but probably easier than that. I at least can think of how to do it. Fun one though. Haven't messed with title. Anything else?
This might be a question if no one has any more direct homework related questions. I never knew before last week that you could use RStudio to create PowerPoint, similar PowerPoint presentations. I was just curious if you'd be able to show like a few of the first steps to doing that?
Yeah, so there's straightforward slides, and there's what I use. Like in this class, I use a pretty complicated method of producing slides because I'm very picky about what things look like. And you probably wouldn't want to use the exact method I do. I use a package called Sharingen, which is really nice, but you can do simpler ones. You could basically just go here to our Markdown or even our presentation down there. So if I just do our presentation, I'm going to go ignore labs one. Lab one presentation. Oh, where did it go? There it is. Okay. So lab one presentation, it will automatically generate all this stuff with some examples. If I click preview here, it generates the preview up here in the top left, and I can browse around and look at these slides. And so this will be basically the exact same kind of code we see in our Markdown doc, but in a slide format. And so these are the default slide style. And then you could just write them like any other Markdown document. Their syntax is a little different. These are slide transitions. Then you can put chunks in, you put titles directly above the slide transition thing here, and that'll be the code. So for instance, if I click, you'll see here, this is lab one presentation. That's the title for the slide. I could do something like quote it.
That's cool. I didn't know you could do this so easily.
Oh, looks like you don't have to quote them. Okay. Yep. So basic slides. Yeah. Oh, yeah. That's excellent advice there from Brian. Another place to start, and where you started, would be to look at presentations in the R Markdown textbook. So the R Markdown guide is online, and they have a lot of information on different styles of slides. So there's things like there's IO slides, slidey ones. So if you ever see like latex style slides that, especially economists and shit love making, Beamer presentations, you can make Beamer PDF-based Beamer slides in R. You can also actually just make PowerPoints. Like you can have it produce a PowerPoint doc. You can do that too. So, you know, whatever works. I use Sharingen, which is probably covered far down in here somewhere as an option. I imagine buried way down in here, they've got Sharingen somewhere. Sharingen is dope. So yeah, it is chapter 7 Sharingen presentations. Sharingen lets you make slides by default. They look like this. They browse, they have a really clear, nice style. The main reason to use Sharingen slides is they allow you to use really nice cascading style sheets if you have a little bit of CSS experience to like put stuff in. And I like very custom built-in stuff. They also let you do things like interactive. Yeah, normal slides, you can do interactive stuff built into the slides. You know, HTML widgets, like this is an actual like browsable table embedded into here that I could search stuff on, you know, stuff like that. A lot of functionality built into slides. Yeah, but I mean, even presentations in classes of mine that have no programming component are all built in R because it's faster for me to generate them than it would be to make PowerPoints. Yeah.
Cool, thank you.
Yeah.
I have a question, sorry again, for
Go for it.
the title of the plots. So it's weird when I run it in like the Markdown, it generates the plot fine like what you have there. But when I knit it, the title, the top, like the main title overlaps with my actual like axis numbers. So my top title would overlap with 0, 20, 40 in the middle.
Yeah, interesting. Let me see what it looks like for me and see if it's doing that. Yeah, I get the exact same thing there. So most likely what that is got to shift it up a little bit. So if we want to shift it up slightly, I wonder why it's doing that. It's kind of, can I just position it slightly higher up? I'll show you a quick super lame cheat, but first I want to see if there's a legit way to do this. I don't see a super easy way to do it. Okay. Add a \n right there. knit it, raised it up a little bit, add another one, raise it up a whole bunch more. There we go. \n is what's called an escape character for line break or return. So I essentially just made the title, this is the top line, generate a new line, generate a new line. So just a lame way of jumping it up 2 spaces. So you could do that as a quick hack. I could probably figure out a way to actually manually adjust the placement, but I figure we're going to move to ggplot this week, and so you won't have to mess with these finicky, weird base R plots much anymore.
Is there like, so this one moves the title up, but what if you want to move it down? Like, would you inverse what you just did?
Why not? Let's see what happens. I mean, yeah, so this isn't actually moving the title. This is actually just making the title vertically larger. This is actually like, this is really just exactly the same as hitting the enter key. And so this is just saying line break, line break. So now, technically speaking, what this title, what R reads this title is as, oh, replace this with a return, replace this with a return. So the entire title, as far as R is concerned, looks like that if I add these 2 backslashes in front. So because there's all this space, it just centers the title here, but this would make it move down, whereas what we had originally is basically this plus a line break and another line break. And so it ends up looking like it moves it up. You see what I'm doing? Stupid tricks. So
I see. Thank you so much.
yeah. Often this is the kind of the solutions to your problem. See, now it just moved it down because basically it's centering it, but there's a line break. And so there's a line here and a line here, but they're just blank. And so I just shoved it down a bunch. Yeah, these are stupid R tricks, but you know, they work. And that's generally what programming is about, is, you know, especially for like social science programming and stuff, it's just make it work. It doesn't matter if it's a beautiful solution, it works. Okay, let's see.
I have one more question for you about, I've used R before for other classes. I've been introduced to a lot of different packages, usually for the purposes of 1 or 2 functions to try and, you know, solve whatever problem it is we're working on. But I'm curious about trying to unpack a little bit more how these packages work and kind of what's the range of functions that are in them. And I'm curious, do you have a process that you go through or a way you think about trying to understand how a package works, what the different functions are that are available, or kind of the limits of what a particular package is good for?
Yeah, there's a couple things you can do. If you're completely comfortable with R documentation, you can typically just do something like look at the documentation for a particular package. Like I just opened up the documentation for dplyr package. We're gonna obviously use a ton this term. And then you could do things like, for instance, this one says to learn more about dplyr, start with the vignettes. I could literally just run that vignette, which is then going to open up a browser window that has browsable, like here's an HTML introduction to dplyr, and gives me an idea of all the documents. So basically all these things are well documented, right? You could see the things in there. Another thing I could do is I could, I could go down here and I can just look at the index of the package. And this is every function in the package. And so you can see, you know, dplyr has a lot of functions in it. There's a lot of things in there. That's pretty common. Some packages have an enormous number of functions. Most of these are things you might not, I mean, many of these are things you would use directly and you don't really need to know about too much. So this camp isn't necessarily the most useful thing unless you kind of know what you're looking for. Typically, if I want to know what a package does, I read whatever documentation there is out there rather than getting something directly out of R. But it depends, you know, if I scroll up here to the top, it will have things like, you know, I can click here, I can get those same vignettes. Most modern packages have vignettes. And the vignettes are essentially what I clicked on, which are things like, oh, well, how do I do window functions? I can click window functions. It's going to bring up a documentation thing describing how to do window functions in dplyr with all sorts of information.
That's what I think I've been looking for. I've gotten lost in the indexes before because I just have no clue what all the lists are.
Vignettes are usually the jam you're after. Those are the real documentation because that's sort of examples and actual applications and like written out. And they're actually are markdown documents too. So
Awesome. Thank you.
anything else?
I think I'm good. I think I'm going to jump off. Thank you.
Sounds good. No problem.
See you Wednesday.
Yep.
All right.
Bye-bye. Yeah, if nobody else has anything, you're not obligated to stick around. If you are currently working on this or poking at it and you want me to stick around, I'm happy to do that. So just let me know. Otherwise, I'll head out early here in a bit. I'll give you time to answer and mull that over. Yeah, and I'll answer, of course, off and on. I'll probably check Slack. Probably not too much more tonight. But yeah, let me know. Always happy to answer questions. Yep.
Hey, Charles.
Hey.
Sorry, I just logged on and then my Zoom froze. Okay, so I tried to knit the I can't remember what these things are called.
Markdown doc.
The markdown documents, thank you. And I keep getting an error message saying that I can't find Pander as the function. But I loaded the package, so I don't understand why.
But have you up here in one of the chunks in the document, do you have library Pander? Like up at the top.
Oh, I didn't put it between, what are these marks called?
So yeah, the whole thing is called a chunk. And so this is a chunk header and a chunk footer.
Oh, okay. So I had put library and then bracket Pander outside of the chunk. So it won't read it.
It won't read it. It just thinks it's text.
Oh, okay. So anything that I wanted to read as a command needs to go in a chunk. Is that right?
Exactly. Or you can, of course, have these like inline R1s, but even these things still say backtick R, which tells R, I'm going to give you some code. Same thing here. It's 3 backticks R, and it's like, oh, you're going to follow this with some R code. So you got to tell it.
Oh, I see. Okay.
Yeah.
Okay. Thanks.
Ooh, can you go over how to submit multiple files on Canvas at once?
Oh, sure. It's actually a good question. I know it always happens, but I never do it myself. So let's find out. Okay. All right. Yes. Okay, so if I pretend to be a student, and I go into homework 1. Okay, so let me see. Upload a file. Choose file. I think you could just upload one and then upload another one, right? Let's go down to.
Okay. And to be clear, is it?
Add another file. There we go.
Okay, that makes sense. Is this a one-time submission or multiple?
What do you mean?
Like, can we submit it multiple times? Or
Oh
is
yeah,
it
I
one
don't care.
time? Okay,
Do whatever you want. Yeah. Pretty easy with late work too. So if you find struggling with something, you need an extra like day or two on something like that, submit it a little bit later. It's This is just trying to be maximally useful, minimally stressful, do whatever works for you.
Okay, thank you. I gotta head out.
Sounds good. Have a good day.
Hey,
Hey.
I have a couple other questions. One is very basic, but basically like when I started creating chunks, initially I had called them all like R space Swiss for some random reason. I don't know why. But like I got an error message when I went to knit it and is that because it's basically was it like assigned the same name value or something like that?
Yeah, they gotta have unique names. So I do one of two things. I either don't name any of them, like this, which is fine, or I will be like, you can say like this is chunk 1, this is chunk 2. That should work. If I name them both, 2 of them chunk 1, he's gonna get real angry at me. So if I do chunk 1 here, it's gonna be like, yeah, exactly. Duplicate chunk label chunk 1 has been used for this chunk. Yeah, so easiest thing to do is to either change them all or not name them. I often don't name them, but naming them gives you one advantage in that it adds a little table of contents over here. And if they're named, it makes it easier to find them. But that's really only important for big documents.
So why doesn't it think that it's being duplicated if you just have R in there without a name?
Because then it has just no name. Unnamed, it's perfectly fine with that. And so that's actually the default. So the idea is that names are supposed to be something you would add to a chunk if you want to uniquely identify it. If you don't want to uniquely identify it, you leave it unlabeled. Yeah.
Okay. And then the second question was, I tried to use the Pander line to create the table. And in your slide deck, it looked like every other row had like a color.
Yep.
But mine doesn't show up with the colors. So,
nope.
Like, is that an additional thing?
Okay. That's actually based on the template that you're using. So it just so happens that the Sheringham template I have built into my slides does every other line with a purple bar. And the default R Markdown template doesn't. And so I keep forgetting what I actually ought to do is just change that because I get that question every single turn. And so it's actually that there's the CSS in my slides, and I can actually go in and basically if I scroll down, where is it? It's I know you're in here somewhere. Yeah, there's every other slide or every other row of the table. Oh, this one actually has it removed, as a matter of fact. Look at that. Yeah, basically it's something in my CSS that I haven't gone around to deleting, and so it just induces confusion in people. You could theoretically do that, but you have to modify these like style sheets underneath it, which is a really annoying thing to do. So unless you know some cascading style sheets, I wouldn't recommend it. But there's probably templates out there that you could swap your document to and would do that. Which is something you could play with if you're interested. Yeah.
I'm gonna pass for now.
Yeah.
Okay. And then was there like how many tables and like plots did you want us to make?
Just however many. One of each is perfectly fine by me. If you want to do more for playing around, do it. It's just one of those things where just a bare minimum, and whatever you're comfortable with. If you want to play around with stuff and experiment, go for it, but not required to do much.
Okay, thanks.
Absolutely.
Bye.
Bye. Okay, let me stop. How do I do this?
Oh goodness, did I jump?